So I'm going to record for, okay, on your grid. Ignore that point right now. Just go graph that. So where'd you go? -4. That's the y-intercept. And then what? Over 1 up 2. Over 1 up 2. Okay? Now, and don't draw a huge line. Just draw. You don't have an ID? I don't care. Go get them over. We're not going to do that many, but don't put that many points on there, please. You only need 3 points on your line. Only need 3 points. Okay, now go graph y equals 2x plus 2. Okay. So when you graph that, that's plus 2. I'll let Colton have time to. Okay, so plus 2, so you're going to go over 1 up 2, over 1 up 2. Okay, you're going to draw your line. What do you notice about the 2 lines? They're what? Parallel. So there's no solution, right? There's no solution. There's not a point that goes through both of them. Okay? That is connects them. We're going to learn that later. But these 2 are parallel. What do you notice about the equation? What in the world? They have the same slope. Do you think that works every time, that if they have the same slope, they're going to be parallel? Well, let's do another one. Okay, erase that. Let's do another one. This time, let's do y equals -2/3 x plus 1, and y equals -2/3 x minus 1. Same slope. Let's see if they're parallel. Okay? Are they parallel? Guys, every time the 2 equations have the same slope, they're going to be parallel. Every time. Every single time. Now, if these are the same, if the y-intercepts are the same, it's the same line. True? But if the y-intercepts are different, same slope, the lines are going to be parallel. You automatically know. Okay, so erase. Now, that point, -3, 5. The same equation. If I want a line, an equation of a line, if I want an equation of a line that is parallel to this one, but goes through that point, if I want, hey, don't put it back in here if it doesn't work. Oh, okay. Guys, if I want an equation of a line that is parallel to that one, I don't want that one, I already know that one, I want another one that's parallel to that, but it goes through that point, those points, what do you think I'm going to do? What do you use? Okay, well, you know that it's going to be 2, right? 2x. Why do I know it's going to be 2x? The slope's going to be the same. So I know that the slope is going to be 2. I have, you're right, Dylan, I have the slope, I have a pair of points. I have the slope and I have a pair of points. So all I'm going to do is go y minus 5 equals 2, open parentheses, let's write, y minus 5 equals 2 times what? X plus 3. So I use the point and the slope. I know it's going to be the same. Go put it in point slope, and then I can get it. So y minus 5 equals 2x plus 6, huh? Plus 6. Now we're going to add 5, and y equals 2x plus 11. Okay, let's do another one. The point is 4, -1. You can do it on the white side or grid side. It doesn't matter. We're not graphing it. 4, -1. Oh, wait. They wanted to. Okay, guys. Well, this is going to be interesting. Okay? It's parallel to the x-axis. It's parallel to the x-axis. So what's the slope going to be? Good. If it's parallel to the x-axis, it's going to be horizontal. It's going to be, the slope is 0. So, go. Write it in point slope form and stop. Okay, what did I do there? So what's it going to be? Right? Okay? So, that's the point slope form. If I want it in slope intercept form, it's going to be y equals -1. So, let's think a minute. On the graph, you don't have to graph it, but let's think just a minute. 4, -1, y is -1, right? So, that's going to be the graph. That's going to be the line. That's parallel to the x-axis. True? Okay, here we go. Now, let's do either side. It doesn't matter. Okay, here is the point. -1, 2. And the equation is y equals 1/2 x minus 3. I want it in slope intercept form. Okay? Y'all got it? Okay, what is it? Y minus 2 equals 1/2 x, that is right here, plus 1. You're using your x and your y right there. There's your point, there's your slope. Point slope. So y minus 2 equals 1/2 x plus 1/2. Add 2, y equals 1/2 x plus, good, 5/2 or 2.5, 2.5. Because that's the y-intercept for your other line. You're trying to find another line that would be parallel to that. So it's going to have a different y-intercept. So that's nothing to do. You don't need it for anything. No. Okay. Hey, write this down for me. Y minus 8 equals 2/3 x plus 3. What kind of form is that when you see it? Point slope. That's point slope form, right? Slope intercept says y equals. Y equals the slope intercept. And it's on your reference chart if you need to. Okay? Who can tell me what the slope is just looking at that? Good. And what is the point that that goes through? It's the opposite. Because you go x minus a -3, which makes it x plus 3. So that is, you need to be able to look at that point slope form and get this information from it sometimes. So that's the slope, and those are your points. The opposite of what it says. True? Okay. So, if I wanted a line that's parallel to that, well, no, never mind. Let's go to another one. Okay. Let me get one more. I think that this is pretty easy, huh? Oh, I know what I need to do. Oh, they made them easy in the book. Okay. What if, let's do one more. 3, like this. 3 negative 2, y equals x plus 4. Three negative 2, y equals x plus 4. You already have it, huh? Surely. So y, come on, y plus 2 equals, you need x minus 3? Look, you're using your point over here. All you're needing this for is the slope. And you can put 1 there. You don't have to, though. And so y plus 2 equals x minus 3. Subtract 2. Y equals x minus 5. See? Did everybody get that? Okay, what if I gave you this equation. 2x minus 8y equals negative 12. Okay, what would you have to do first to get the slope? You have to get y equals, aren't you? Put it in y equals a slope-intercept form, and then you'll know. So I'm going to subtract 2x. So negative 8y equals negative 2x minus 12. Oh, what could I have done first? I meant to do that and I forgot. I could have divided by 2, all across the board, but it's okay. Now we're going to divide by negative 8. So y equals what? 1/4 x. Thank you, people that know how to reduce a fraction. 2h reduces to 1/4. Come on now. Plus what? You have a calculator about, guys. 12 divided by 8? Yeah. 3/2 or 1.5. 12 divided by 8 is 1.5. 3/2 is positive because 2 negatives. Okay, so now we know the slope. Now we know the slope is 1/4. So everybody sees how we did that, huh? So you got to put in that form. Now you know the slope. And so if it goes through, I was trying to make it really easy, but I think I won't. Negative 2, 4. Negative 2, 4. What are you going to do? I'm going to write real small so I can get it on my paper. Y minus 4 equals 1/4 x plus 2. Y minus 4 equals 1/4 x plus a half. Good. Add 4. Y equals 1/4 x plus what? 4.5. You could say 4.5 or 9/2 is good. Okay. Does everybody get that? You think? Okay. That's all we're going to do for right now. And then we're going to come back and do something else. So if it's parallel, they're going to have the same slope. Okay, now we're recording and we're graphing these two equations. Okay, you got them? Okay. I want you to notice something. I want you to get your piece of paper. Get this piece of paper. Stick it in there in that angle where those two lines intersect. Put it right there. What do you notice? Well, it's a right angle, huh? That's a right angle. 90 degrees. It's a right angle. Who knows what that's called? When two lines intersect and they make a 90-degree angle. Perpendicular. It's perpendicular. They're perpendicular lines. Notice the slope. Look at the slope. That's 4. That's negative 1/4. Hey, everybody look at it. Okay? All right? Now, let's do another one. Right set. I'm going to keep mine. So now let's go do y equals 2/3 x plus 1, and y equals -3/2 x minus 2. Go graph those two. You got it? Put your paper in there again. Does it make a 90-degree angle? It does. Yep, exactly 90 degrees. So they're going to be perpendicular. Look, everybody circle your slopes. What do you notice, Richard? Right. So it is when the slopes are the opposite reciprocal. Now we're going to do some notes on that tomorrow. But when it's the opposite reciprocal means it's flipped, but it's got to be the opposite sign. So if this was negative, that's got to be positive. So if it's a negative reciprocal, then you're going to have perpendicular lines, not parallel. It works every time. Okay? So let's go to 4-4. Go back to 4-4 and look at number 11. Wait, I tell you what. Turn on the back and let's do those first. 13. Well, you know what? I changed my mind. Get back to your board. Get back to your board. The white side or the grid side, it doesn't matter. Let's do these first and then you can do those. Okay. Write this point down. -3, -2, and y equals -2x plus 4. All those markers are going out, not big time. Okay, so, okay, -3, -2, and that's our equation. Okay, I want a line that's perpendicular to that. So my slope is going to be, what? Say it again. +1/2. It's going to be +1/2. So you have to do the opposite reciprocal. And now you do the same thing we've been doing. So you go y plus 2 equals 1/2 x plus 3. Everybody see? Same thing, except the slope is a little bit harder to do. So y plus 2 equals 1/2 x plus, what do you want to write? 3/2 or 1.5? I don't care. 3/2, that'll work. And now we're going to subtract 2. So 1/2 x, what's 3/2 minus 2? Is he right? -1/2? Hey, how would you do that on the calculator? Tell me. 1.5 minus 2. You could turn that, or you could come over here and just go 2 minus 1.5. There's all kinds of things you can do. Or 1.5, not 1.5. Okay, so it's going to be minus 0.5. Okay, on the calculator, somebody do, or y'all do this for me. 3 divided by 2 minus 2. Three divided by 2 minus 2. Okay, let's do another one. Yeah, yeah, you don't have to. Okay, it's going to go through 2, 6, and y equals negative 1/4 x plus 3. The first thing you need to do, okay, they want it perpendicular. So it's not the same slope, it's the opposite reciprocal, which is 4. Now go, set it up. Y minus 6 equals 4x minus 2. So 4x minus 8, add 6. Y is 4x minus 2. Okay, any questions about those? Okay, open your book to 242. There's a couple of graphs I want you to look at. Page 242. Hurry. Yeah, go put it in the tray. 242, real quick. Look at number 3. Y'all remember what the parallel symbols and the perpendicular symbols look like? Look at the top of the page on that chart. See it? Remember, parallel looks like railroad tracks. And then perpendicular is upside down T, or that means it's perpendicular. Parallel. Okay, look at number 3. It wants us to determine if those paths are perpendicular on that garden. On number 3. We're trying to see if they're perpendicular. What could we do to find out if those are perpendicular besides put our piece of paper in the angle? Not solve it. No. Get the what? No. Get the slopes of each one. If we get the slopes of each line, what do they have to be perpendicular? The opposite reciprocal. So let's start with AC, and you just write it on your board somewhere. Okay, so AC. Let's go from A to C. The other points aren't clear. So you're going to go over how many were on AC. Well, you know what they said to do? Subtract the points. But hey, let's do rise over run. So we're going to count from A over. 1, 2, 3, 4, 5, 6, 7. Okay, so what is that? 7's the run, so that goes on bottom. Go up how many? I think it's 6, isn't it? Yeah, 6. So that's the slope of AC. Now we're going to do the slope of BD. So we're going to have to go from B over how many? 1, 2, 3, 4, 5, 6. Right? So what's the run? Guys, have y'all forgotten how to do rise over run? Oh, okay. You're going left, 6. And then you're going up how many? 7. Hey, what do you notice about these? They're the reciprocal. They're the opposite reciprocals. So, do you know these two lines are perpendicular? Good. All right. Now look at number 4. A square is a quadrilateral that has opposite sides parallel, consecutive sides that are perpendicular. What does consecutive sides mean? Consecutive, that means on a figure, consecutive, that means, yeah, they're touching right here. Okay, so these are perpendicular. That means they make a 90-degree angle. Y'all have known that since kindergarten, first grade. And the diagonals in a square are going to also be perpendicular. That where they meet 90 degrees. True? Okay, it says determine whether this quadrilateral is a square. So, what could we do? Go to EG. So, go to EG. Let's do the slope of EG. So, EG is what? 7 over -7, which is -1. Now, FH. So 1, 2, 3, 4, 5, 6, 7. So you're going to run 7, and you're going to go up 7, which is, aren't you going to go up? FH is positive, so that's 1. Is that the opposite reciprocal? Yeah, 1 over 1 is 1 over 1, yeah. So this is true. It is a square. Okay, that's true. They're perpendicular. Now, and these are parallel. I mean, we can look at the graph and see they're parallel, can't we? Can't you see that they're parallel? They're on the same. Okay, I think so. I don't think we have to do that. Okay, look on page 243 and number 17. A trapezoid is a quadrilateral that has exactly one pair of parallel opposite sides. So how are we going to determine if, now I can tell that 2 of them aren't parallel. Which 2? A, B, and C, D are not parallel. But BC and AD look like they might be parallel. But all we have to do is get the slope of BC. We're going to look at BC. What's the slope of BC? Rise over run. Good. 1/3. Now do AD. Just look at AD on your, hey, look in your book. AD. So you're going to go over 6 up 2, right? Which reduces to 1/3. If they're parallel, they're going to have the same slope. So those do. So that is a trapezoid. Does that make sense? Well, a trapezoid has only one pair of parallel sides. So we just proved that BC and AD are parallel because they have the same slope. We can see with our eyes that BA and CD aren't parallel. So it has one side. If those weren't parallel, if those didn't have the same slope, it wouldn't be a trapezoid. It'd just be a quadrilateral, four-sided figure. Okay? Now look at 21. It says determine whether these equations are parallel or perpendicular. So on your board, write 2x minus 8y equals negative 24. Write that down first. What do we need to do? What are we trying to find? If they're parallel or perpendicular. So what do I need to do? I need to put in slope-intercept so I can find the slope. So, hey, let's divide by 2 first. What am I going to get? Minus 4y equals negative 12. Subtract x. Divide by negative 4. Right? So we've got the slope of that one. Does everybody have the slope of that one? Some people don't. Now do 4x plus y equals negative 2. That one's an easy one to change. Don't erase the other one. You need all of them up there. So what is that going to be? Subtract 4x. So what are you going to get? Y equals negative 4x minus 2. Okay? Now we need to do the last one. X minus 4y, I'm lost, equals 4. So put it in y equal form. Okay, we're looking at all 3 of those equations. Which 2 are going to be, I tell you what, let's number them. That was 1, that was 2, and that was 3. Which 2 are parallel? Which 2 are parallel? Huh? 1 and 3, huh? Guys, the same slope are parallel. So 1 and 3 are parallel. Hello? Or to people? Okay. Which 2 are perpendicular? 1 and 2 and 2 and 3. Hello? Right? If these are parallel to each other, and that one's perpendicular to that one, then that one's going to be perpendicular to that one. Makes sense to me. Okay? We good? We know the difference in the 2? Okay, now we're going to go finish the 4-4. Start at 10, 11, and go all the way to 18, and then we're going to check it, okay?